My name is Russell Elbrick. I just had a discussion with Dr. Christina Baer, the director of the Scope Imaging Corps at UMass Medical in Worcester, Massachusetts, where we discussed her work at the Scope Imaging Corps and the history of this important imaging facility as a forerunner in the video rate 2 photon imaging space. I hope you enjoy it.
The first thing I want to ask is, can you tell people about what SCOPE is and a little bit about its history?
Absolutely. So SCOPE stands for Sanderson Center for Optical Experimentation, and it's the imaging core facility at UMass Medical School. It's a light microscopy core facility. We have other EM cores. And the scope doesn't have a very long history at UMass at this point. So this core facility was founded initially in 2017. It's named after Mike Sanderson, who was a physiologist and professor in the microbiology and physiological systems department at UMass and had been at UMass since the mid-90s. Mike unfortunately passed away very suddenly in 2016, and he had in his lab a really unique collection of instruments. He had both built his own instruments and was in charge of some of the commercial systems that were utilized by the MAPS department, the Microbiology and Physiological Systems department. And our department chair, Alan Jacobson, realized pretty quickly that this was a unique resource on the UMass campus and actually in central Massachusetts in terms of the capabilities and quality of the systems that were in the facility. So he moved rapidly to create, instead of a departmental resource, a university-wide resource where people could come for advanced imaging approaches and advanced image analysis techniques. We do everything from relatively basic wide field scanning all the way through, again, you mentioned BLIC, multi-photon, super resolution. We've done some light sheet work. So we have a lot of different imaging capabilities and modalities. We have right now 14 microscopes. It goes up and down a little bit depending on what's working on any one day, but that's generally our instrumentation load. In terms of different approaches, TURF, multi-photon, SIM, structured illumination microscopy. We do a lot of wide field and live cell work too, in addition to confocal work. So we have a lot of different microscopes and a lot of different approaches. One of the fundamental things about the scope, and I'll let you interrupt me in just a second, is that we both build our own instrumentation to suit our customers' needs and provide access to commercial instrumentation. And that mix has been really important for our user base.
Okay, all right. Well, actually, I wanted to ask about your user base and just to get a sense for what the distribution is presently and what it's been over time. I mean, what have been the strong points of scope over time and how it supported UMass?
Absolutely. So, going back to the history of Mike and how he kind of founded this collection of equipment and these unique instruments that he built, he was one of the first people to build a video rate scanning multi-photon instrument that was capable of 30 frames a second imaging. And he was really interested in looking at calcium signaling and muscle contractions in live tissue. So that's work that we've continued, and we've been working to continue over the past couple years. It's real fundamental to what the scope does. Our user base is pretty broadly distributed. I think we're up to 18 or 20 different departments at the medical school that we support. Initially, of course, when the scope was first founded as the university resource, the vast majority of my users came from the MAPS department, the Microbiology and Physiological Systems department, because those are the people who've been using the departmental resource. But over the past couple of years, we've been working really hard to expand our user base in the neurobiology department and the neurology department. Pathology uses our systems, medicine, a lot of different investigators do. And we're imaging everything on a daily basis from fairly standard tissue sections, individual cells, to intact whole organisms like jellyfish, which I imaged just the other week. So one of the really fun parts about the job is you never know what each day is going to bring in terms of samples.
Okay. One of the things that actually struck the team at BLIC when we first saw the instrument that Mike had built was it's sort of being a leading, way ahead of its time. I think it was built in 2000 or 2001.
Yep.
And we realized that was a 2-photon instrument with video rate microscopy capability that was way ahead when 2-photon was just coming into use in biology. And I'd be curious to hear, how did that capability help advance UMass Medical in its research?
Well, you know, that capability was really fundamental to what Mike did. And so he studied a lot of, he looked at airway contraction and muscle contraction. So he was mostly a lung physiologist. And he was looking at airway reactivity in asthma in response to different small molecules. He was starting to, when he passed away, expand his research into the area of infectious diseases. So I have some really cool video from my two photons looking at RSV, so respiratory syncytial virus spread in intact lung slices. So one of the areas where Mike was a real pioneer was not only in just building these multi-photon microscopes, which were very cutting edge in the early 2000s, as you mentioned, but also he made a number of innovations in terms of sample prep. And so that's, I think, really, really key, because you and I both know your images are only as good as the quality of your samples. So if your sample prep is not optimized for the type of microscopy that you're doing, forget it. You're never going to get good data.
Okay, so 20 years goes by, and then the instruments are in a different state of operation. And so that's where you kind of invited me in to take a look, and I was excited to see that, because I think it's one of the strengths of Blick's team is be able to look at these equipments and envision how to bring them up to a current level. And I wanted to ask you about the system that you've got there now, and how it compares to what you had, and what the response of the community has been to it so far.
So I started as a postdoc at UMass in 2011, and I only took over as the director after Mike passed away in 2017. But during that time, I had worked on these two photons quite a bit. And I was studying Mycobacterium tuberculosis, which is a bacteria that causes tuberculosis infection, and trying to see what sort of deep organ tissue imaging we could do that would help us pinpoint areas of infection and look and see how the infection progresses. And using the two photons was really a way to do that. So this was in the pioneering days of a tissue clearing, when everybody was clearing everything. And so we were starting to look at real thick tissue sections. And two photon was really the best way to do that we had on campus. The systems were incredibly frustrating to work with. Mike was the whisperer for these systems, right? Because he built them. And so he understood exactly how to fix every problem. But you had to work directly with him, literally next to him, to get the system to behave the way that you needed it to get your data. So he was very protective of the systems, and they were absolutely phenomenal. But unfortunately, again, when he passed away, we lost so much of that knowledge base. And the systems at that point had really aged to a point where we needed to move them to the next level. You know, with the advent of commercial video rate scanning multi-photons, and the new control software that's out there, and some of the new control hardware that's out there, it was very clear that these systems were becoming obsolete. Now, the lasers and the optics were just fine. But when it came to the control electronics and some of the slightly odd things that were done in the optical train when the systems were first designed. So Dr. Sanderson was a fantastic biologist and a fantastic engineer, but he was not a trained optical engineer. And so I know that when the Blick team broke down the systems initially and began to rebuild them from scratch, they found things in those systems that I would never have found unless I had, taken them apart completely. And so it was absolutely critical that we had the Blick team of engineers to back us up on this system. The systems right now are phenomenal. So I can't tell you enough how exciting it is to go into that room, flip the switch, and have it just work.
Okay, that's a good thing.
Yeah.
How would you characterize the system, the differences of the system? If you think about the way Mike built the system and how it's evolved to the unique aspects of the Blick system, could you explain?
Well, we moved from a Galvo system and a scanning system to a polygon, right, and a polygonal scanner. And so that's a bit of a fundamental change. It's not a change that the users are necessarily going to notice right away, but it does allow us some advantages in terms of the system functionality and what the systems are able to do. What I can tell you right now is that the systems themselves are working at, again, at a level that we haven't had them work in terms of being able to work consistently, get data across weeks to days, and get us the information that people really need for their intervital imaging, which is the main use of those systems right now.
With frame rates of 30 frames per second and higher, depending upon the field of view. And do you see people, can you foresee people using very high frame rate imaging, hundreds of frames per second on the system?
Absolutely, yeah. Mike's original systems were designed to go up to 120 frames a second. Yep. But when I opened up the control boxes, I discovered that the lever told you could go to 120 frames a second, but it was never wired up to do so. Okay. I think largely because we were running into hardware limitations of what was available back when those systems were designed. So now having the capability to really start to push the frame rate, it's going to change things in terms of what we can image when it comes to molecular dynamics and other very fast processes that, you know, we were limited to our 30 frames a second.
Okay. I'd like to ask you a little bit about your impression of the Nirvana software from Blick, and also looking forward, what you feel are the most important attributes of the collaboration with Blick that will help you go, to move forward and to implement your plans for how Scope will grow and where does it come together?
Well, Russell, you know that I have 4 multi-photon systems. We only upgraded 2 of them. So, so we've got some other ones waiting in the wings potentially for Blick to help with. But so the Nirvana software is, again, just an incredible advance over what we were using previously. So we were using software that was not coded in-house, but that was custom coded for us by a company back again in the early 2000s. And it was just very clunky. It was never designed to run a multi-photon instrument. It was just an adaptation that they'd kind of built into their own code. Mm-hmm. So the Nirvana interface is incredibly clean. It's incredibly easy to use. And I've had a number of users come over who have used other multi-photon systems, who are used to Zen or, NIS Elements or other things. And the speed at which they pick up Nirvana has been really, really great to see. And it's really been critical for them on their uptake on the Scope systems, because having had these older systems in the Scope, I'm not the only user that was on them before Blick came in and upgraded them, and we developed a little bit of a reputation of having these difficult multi-photons that sometimes would turn on, sometimes would work properly. They were running Windows 2000. The computers weren't stable. They had been when they were designed and built, but after 15 years, your OS is not going to be stable and your system's just not going to be able to handle the data collection in the way that we need them to. Right. So, now people are starting to realize, like, oh my gosh, I can just show up with my samples and get the data I need. And, one of the things that's been really great too is that the Blick team has been very responsive. When we have questions about Nirvana, when there are things that I'm not explaining well to users or we run into a stumbling block, the team is incredibly responsive and is willing to jump on the computer nearly instantaneously most of the time and, walk us through the issues and figure out what we're doing wrong, because 90% of the time is an error on our end.
Okay, well, I want to say that I think I speak for the whole Blick team and just being very appreciative for the opportunity to work together with you. And I know that they like the challenge and they enjoy new challenges. So we hope that you bring some more along.
Absolutely. Well, I think the entire team kind of their jaw dropped when they saw the older system and were like, oh my gosh, Russell, what have you gotten us into? But all of their hard work really paid off in this case for us. And so I, can't give them enough thank yous for the work and effort that I know they put into custom designing these systems for us. So we certainly would not be anywhere near operating at the capability we are without that help.
Christina, thank you very much for your time today. Thank
Absolutely.
you.
Anytime, Russell.